So we are still on our quadratic functions, further mathematics, and roots of quadratic equations, right? That's one next subtopic, roots of quadratic equations. Now there is a general quadratic equation. That's a formula. Sometimes called the almighty formula, right? There's a formula. So you can have it this way. Okay, x equals what you see. Good. So that's the formula. Now b squared minus 4ac equals delta. This is a symbol. It is called a discriminant. What's a discriminator? Someone who discriminates, right? Okay. I don't like you. Like you. I don't like you. I don't like you. You are from here. I don't like you. You are from now. That's a discriminator, right? So it means b minus 4ac equals delta is a discriminant. So when you solve employing b minus 4ac, you are going to get something. And that b minus 4ac is going to tell you whether you have two real roots, you see, it is discriminating, or whether you have two real and different roots, or you have no real roots or complex roots, and that is it. So this discriminator will discriminate. That is why we call it a discriminant, right? Since it determines the nature of the roots, you see. Good. Now, if b squared minus 4ac is greater than or equal to 0, so when you solve b squared minus 4ac, and your answer here on the left is greater than or equal to 0, then the equation will have two real roots. This thing will not appear. This is a discriminant as well. And when your answer here is greater than or is equal to 0, then the equation, the nature is that it has two real roots. That is all. Here, b squared minus 4ac is greater than 0. If you use b squared minus 4ac and you get an answer here, maybe 8, which happens to be greater than 0, then the equation will have two real and different, or what you call distinct roots. Take note. If it is greater than or equal to 0, the equation will have two real roots. That's equal, greater or equal. If it is just greater, then you have two real and different roots, or what you call distinct roots. Now, b squared minus 4ac equals 0. If you solve, and the left hand side here is 0, equal to another 0, then the equation will have two real and equal roots. Right? Two real and equal roots, right? It's similar to this. This is two real roots. It's not strange because this is greater than or it's an equal to. And this one is what? Two real and equal roots. So those are two real and equal roots. This is just two real roots. Now, if I solve this and I happen to get an answer here like -4, which is less than 0, the description is that the equation have no real roots or complex roots. Okay. Now describe the nature of the roots of the following equation. I can't describe this. I need to call this discriminant to help me discriminate. Right? So I will use the discriminant to check whether it is two real or what equal. The last time here. Now the first one. I have 2x squared minus x minus 1 equals 0. I will compare this to general quadratic equation, right? General quadratic equation, right? That is ax squared plus bs plus c. You see, the general quadratic equations of the form ax squared plus bs plus c. This means you are supposed to see quadratic expressions like this. This happens to be your a. You see, this thing here happens to be your b, and this is your what? Your c. So let's look at something here. Compare. A is 2. Do you agree? There should be something here, right? Because that does not written as a coefficient 1, okay? So this b happens to be -1. Agreed? Now c is a number without a variable. So c is equal to what? -1. How does that explain? Okay. Now I want to know the nature. I have to use the discriminant, right? So using the discriminant, b squared minus 4 is good, right? So b squared minus 4 is there's a discriminant. This one here. You see that b squared minus 4ac equals delta. That's equals something, okay? Something. You don't know that, right? So b squared. So we have -1 squared minus 4. A, whenever you see A, you insert 2. C happens to be negative 1. You see? Good. So what are you going to get? Minus 1 square will give me 1. Okay? Minus 8. Minus 8 by another minus 1. That's positive 8, right? So minus 1 plus, positive 1 plus 8. You get 9. 9 happens to be greater than 0. Do you believe that? Let me ask you a question. Is 9 greater than 0 or 9 is greater than or equal to 0? What do you think?
It's just greater than 0.
9 is just greater than 0. 9 is not greater than or equal to 0. It's not true. 9 is just greater than 0, right? Then you see this in here, then you watch here. Let's go. What's going on here? Here. And the equation has two real and different roots. What do you think? This condition is this. Look at it. You see what's going on? Okay. Therefore, equation has what? Equation have two real and different roots. Good. That is it. I'll be asking this. So please take this here, right? 3x squared minus 2x plus 4 equals 0. So I'll still compare, right? I'll compare to ax squared plus bx plus c equals 0. Now, during the comparison, let's go. This a is 3, agreed? Because see, it is closer to the x squared. This is so closer. So the one here happens to be the coefficient of this x squared. So a is 3. B is negative 2. This minus belongs to this 2. Good. From algebra. And C happens to be free without any variable. That's what you see, right? So C is 4. Good. Now you use the discriminant. B squared minus 4ac equals delta. Delta here. You have to get an answer here, okay? I'll be an answer here. Or let me get it this way. B squared minus 4ac, that's okay, right? So let's go. That is minus 2 squared minus 4. This is A and this is C. We happen to get something, okay? Good. Okay. I can still maintain that. That's right? Now, 2 minus 2 squared is 4. Please, when you plug this on the calculator like this, you get a fake answer like this. So when you are punching the negative answer square on the calculator, please put it in brackets. And it will come out as what? Positive 4. Okay. So 2 squared is 4. Minus 4 times 12, right? What are you going to get? Okay. Wait, I can even come down like this for you. Let's go. This is 4, right? Minus 4 times 12. Minus 12 like this. 48, right? What are you going to get again? Negative 44. Now this negative 44. Is it greater than 0?
No.
Is it equal to 0? It is rather what? Less than what? 0. Good. You see what is going on? Then you go back to your notes. Wow. There's somewhere here. That discriminant happens to be less than 0, as I'm seeing here, right? So the equation has no real roots, or what you call complex roots, right? Good. Therefore, equation have no real roots, right? Let's look at this application. What values of n makes the expression have equal roots? So there is a constraint or the condition given here. So I have to know what equal roots is, and I'll code that, right? So solution to the problem. So I have x squared minus mx plus 4 equals 0. Compare. You compare to what? Ax squared plus bx plus c equals 0. Now, you take your A happens to be 1. Now, your B is negative what? N. And your C here happens to be what? 4. Good. So, for equal roots, we have b squared minus 4ac equals 0. Is that not a condition? If I was told for two real roots, I would say b squared minus 4ac is greater than or equal to 0. So you state a condition for equal roots, right? Good. Now b squared minus m squared, a and c equals to 0. Now minus m squared will give me positive m squared, right? When you square a negative number disappears, okay? Minus 16 equals what? 0. Now I carry this over here as a way of grouping. You see that? I'm going to get positive 16. Now take note. This can form a root on this. That's a principle in mathematics. It's from indices. Now when you take the roots of 16, you see you are going to get something called 4. But remember, from the general quadratic rule, right, you see plus or minus. So anytime you take a root of an answer, although this is what we show in the calculator, it is always plus or minus answer. Sometimes they are just ignored, but that is the truth. It's always plus or minus answer, right? From that general quadratic formula. You understand? So you see, they asked me to find the values, not just 1, 2. So it means m can be equal to positive 4, m can be equal to negative 4. That is why you say plus or minus. Now let's check the alternative. If you want to verify this plus and minus principle, let's see. You see this in here. It happens to be a difference of 2 squares. Can you see that? Difference of 2 squares. This is a square, this is a square. It means you add them like this and subtract them this way. So you can equate the whole of this equal to 0, right? You have m equals negative 4. Also, I can also pick the whole of this equals to what? 0. M equals 4. Now look at what is going on here. Those who want to go through the normal way, you see they have this. Yeah, they have 2 answers. So if the principle of plus and minus is not really true, that was true. It's true, right? If not, you'll be tempted to believe it's just 4. So do you see that when we take a root of an answer, it's always plus or minus? This is a proof. So this, do you understand? Okay. Just that sometimes, you know, when you are working, yeah, you ignore that, right? You ignore that part. It doesn't mean it should be. No, that is it. If you want to ignore, fine, but that is the truth, okay? Because this is proven or attesting to the fact that this plus or minus is not correct. Please, all we can see that. But